You're going to try it.
Well, you have to eventually say them at some point. So let's do a quick run through. Halsafjorden, Julsundet, Romsdalfjorden, Sulafjorden,
You're starting to sound a little
Valdalsfjorden,
German.
Nordfjorden. Yeah, well, that's the
Fjorden.
I'm Sognafjorden, Bjornafjorden, Langenur, Bokniafjorden. There we go, done. I've done my turn. Off you go, Carlos.
Halsafjorden.
Yep, good. I think so. I'm marking it like I know. Okay, yeah.
Yeah, you're right.
Yeah.
Romsdalfjorden, Sudafjorden, Vartdalfjorden, Nordfjorden. Is Fjorden fjord then? I'm guessing. That's my take.
Very good. Well done.
Boknafjorden. So in the other article, the version I'm reading, it's fjord instead of fjorden.
Yeah, that's the English word.
Yeah.
The English, yeah.
I'd say we were pretty bang on there.
Again, I'm answering like I know.
Yeah.
Welcome back to the Off-Site Podcast. I am Jason Lancini, joined once again by Carlos Cavallo. Carlos, you're in London. How is things, mate?
Yep, we're all good, thanks. The weather is warming up. My son has started sleeping and things are looking up. So all good. How's Germany?
Very good. I will start off with weather chat. This is the new opening segment. So it's snowing again. And yeah, it's very
Sorry, was that
cold.
too British for you?
No. I figured that's what any of the listeners are here for is weather updates.
Weather update from a week ago. That's what they want.
Yeah. But no, it's actually interesting. From a weather perspective, it's been snowing. It's been like maybe getting to +1 in the entire day for the last couple of days. It suddenly goes tomorrow. The low is 5 and it goes up to like 15. It's like a 15-degree swing in the course of a day.
It's almost concerning.
Yeah, I was starting Googling like what's going on, and no one seems alarmed by it at all.
Yeah.
A lot going on in the news.
That doesn't feel natural. Sorry, carry on.
No, I was just going to say a lot going on in the news this week. Anything worth covering? Let's maybe introduce the topics for the week, and then we'll circle back. Actually, so the things we're going to cover on the list today are actually one of the most interesting and amazing projects that you've never heard of. I've never heard of. I don't think many people have heard of, which is a plan to replace. That they've actually started work on to replace every ferry crossing across over 1,000 kilometers of coastline in Norway. Amazing project that I was totally enthralled by. Then we'll revisit the news from about a week ago, which was the announcement of a partnership between WSP, the engineering design house firm, with Microsoft, where they're doing all sorts of things with regards to data centers and AI. And then you actually came across a really cool piece of technology that seems to be able to magically turn 2D sketches into 3D BIM models, which we independently spent some time diving into, and we'll posit about where that could go into the future. But anything else that was in the news this week or anything that's worth covering?
Yeah, one notable new project announcement is so China's developing I think it's the world's first deep sea research station that will house up to 6 people, but can be controlled remotely. But it's 1,000 meters down on the seabed, concrete structure, which they've sort of branded as exploration, scientific, marine-based research and all sorts of things like that. But then there's an article that sort of highlights the fact that the world's biggest methane resource is underneath that patch of land. So are they actually looking to extract resources there? Because obviously methane could be used as a source of energy. Yeah, it looks a bit James Bond supervillain. And who knows what they're really intending on doing there, but I'd love to see how you build a concrete structure 1,000 meters under the sea.
Yeah, it's like we're going to do this research project in the middle of, I don't know, maybe the South China Sea, and then you like see them packing it up with all the gear that they're bringing. It's like a bunch of flags, you like plant territory flags. What are they for? I don't know.
I bet they keep mistakenly saying lab. You're like, oh no, research facility.
Yeah.
Another really weird point from the article is the research station can be remotely operated even from space. It's like, why is the land to space thing relevant? And what are they planning on doing to Earth? Are
Yeah.
they going to operate this thing from space? It's like, yeah, it was all a bit Doctor Evil for me, but it will be cool to see how they actually build it. But yeah,
if anyone does a like audit of like where they can save money across the Chinese government, I've got a few suggestions. Maybe the space controlled undersea research facility.
Yeah. And not to put a pun in there, but there's something a bit stinky about this. Is methane smelly?
I was like, is the underwater smelly?
Yeah.
All right, we'll move on. So I've spent an unfair amount of time diving into and learning about this project that we're talking about. So let me give you a bit of a setup. Along the western coast of Norway is effectively just a coastline full of these epic, beautiful fjords, which effectively, for anyone not looking at the picture that I have in front of me, is a bunch of like kind of narrow stretches of water and big towering cliffs that dive like straight into the water. And you can imagine from an infrastructure perspective, building roadways along that coast is difficult. Currently, if you drive the 1,000 odd kilometers from top to bottom, it takes about 21 hours, which if you do the math is really slow. I won't attempt to do the math in real time. So that has a big like cost of the ability to move people around and goods around the country. So it's this E39 highway runs the sort of 1,000 kilometer length along the coast. Along there are several ferry crossings. Basically, you drive till you hit one of the fjords, and then you get a ferry across, and then you keep driving. And they have had the Norwegian government has had a long-term plan to create this uninterrupted ferry-free route that could basically halve the travel time. So saving almost 10 hours or 11 hours for every person doing that top to bottom route, especially from a goods transport perspective, would be epic. What is particularly interesting is that it involves several very unique and sometimes first of its kind type of mega projects to create ways to span these fjords. And so the project itself is still, the overall highway project is still largely up for discussion inside of the country, but they have started on some of them. So there are three probably bits that are most notable to probably double click into. So along the route, there is a currently under construction Rogfast subsea tunnel. So it's a 27-kilometer long tunnel, which will become the world's longest and deepest subsea road tunnel when it's supposed to open in 2033. It gets to almost 400 meters below sea level to replace one of these ferry crossings along the way. And the budget of what's currently being delivered is about $2 and a bit billion US dollars, which in the scheme of like world's largest and deepest tunnel seems very reasonable. But in the scheme of like, this is one of many ferry crossings, you add all that up, it starts to get expensive. But so this section is currently under construction by a couple of different contractors, including Skanska. The other two notable elements of what's proposed is a crazy 5-kilometer long floating bridge that has 300-meter suspended spans for one of the fjords, the Bjornafjorden. And effectively a floating bridge. So just to give context to the scenario, you've got these fjords with very, very, very steep walls and very, very, very deep water. And so that makes traditional bridges that would have to have pontoons sunk to the depth to hit, bedrock, increasingly infeasible. And so the idea is that you have, in this scenario, a set of floating pontoons that then support a floating bridge across this 5-kilometer span. The third bit, just if that wasn't ambitious enough, is there is a kilometer or more wide fjord. There's a kilometer deep fjord, I think called Sognefjord. I'm going to botch every one of these. They are looking at submerged floating tunnels. So a kind of like Archimedes bridge style structure, which would have these segments that were tethered to floating pontoons that hold the bridge in place and effectively hold the tunnel in place, and it's effectively like 20, 30 meters below the surface of the water. This is a super interesting collection of projects in this overall scheme in some of the most unique landscapes in the world. Yes, some of it has real wood behind it and underway. So that's kind of the setup. Each one of these things is a topic to dive into. I don't know if you've got somewhere that jumped out to you to start.
I think just also in terms of the landscape, we've got these 1,000-meter deep fjords. The mountains are 2,500 meters high around them as well. So the elevation you've got to deal with, and which is why there's such an extreme design, is wild. And it must be an engineer's dream for the type of project to work on, based on that.
Engineer's dream, QS's nightmare, because basically you end up with this scenario where, traditionally when you're building a tunnel, there's like some trade-offs, right? You've got like a bridge becomes feasible on up to certain widths and up to certain depths, and then suddenly a tunnel starts to make more sense. But then the problem with the tunnel is you need to be able to get traffic progressively at a reasonable gradient down to the depth that they need to cross the whatever you're crossing. And traditional, say, bored tunnels need to tunnel through the ground underneath the water. You're actually going underneath the body of water. And so when you're in these unique places where you've got people driving at like plus 1,000 meters and the need to like get to more than minus 1,000 meters in depth in order to actually get to beneath the water body, when you start like plotting how far it would take on a gradient, you end up having to start tunneling like so far back that it becomes like, I think, economically infeasible. Not to mention that it doesn't look like there's any shortage of very hard rock in the images here as well.
Yeah. Obviously the Scandinavian countries are very well known for being environmentally friendly and very considerate of the climate around them. And the design very much looks pretty nailed on in terms of minimal disruption to everything around you, because by floating these pontoons, you're not tearing up the seabed, you're not throwing TBMs through, you're not causing too much damage. It feels like quite a nice happy medium. And I think they have quite a lot of cruise liners that go through. So these spaced out pontoons with either a suspended tunnel or a floating bridge above them feels like a good space to be, because it's kind of minimal disruption. So it's quite impressive how they've managed to do that. And the length of this thing is crazy. Like, we know the coastline in Norway is extremely long, but a 21-hour drive that's a serious amount of time to be heading down one of these highways. But it does make you think how tough this must be logistically. It's not like it's a bit of a flat coastline with all these fjords. So from a logistical point of view, transporting all of these materials into these sites must be a serious challenge in itself, which is kind of doubling down on the value it actually add to the residents or the local community when these things are open. Yeah, you wonder if, you'd be setting up mini sort of construction villages or temporary stations along this route to sort of pull in materials, house them, and have these sort of logistics hubs to be able to actually operate each construction site, rather than just endless stream of trucks trying to navigate their way through what looks like quite complex systems.
Yeah, you get the problem of the trucks have the same problem that the solution is trying to solve. Do you, a fun quiz time. Do you know why it's called an Archimedes bridge?
I must have been sleeping that day in philosophy. No, I don't.
No, Archimedes was more of the engineer type. So he has this Archimedes law that basically defines this idea of buoyancy, where effectively the buoyancy of an object equals the weight of the displaced water.
Right.
And so you obviously have these tunnels made of, when I say these tunnels, first of all, it's worth noting that no submerged floating tunnel has ever been built. They've been proposed a bunch of places around the world. And going back to many of our previous conversations about in construction, you probably don't want to be the first person to do something.
Yeah.
There's been a lot of proposals of these around, a lot. There's been a few of proposals of these around the world and never built due to the hesitation of the engineering challenge. There are many engineering challenges with them. So first of all, you've got very heavy materials that need to be floated. So you have to get a way through ballast to float them. They also need to kind of have like a equilibrium of buoyancy, so that the amount of ballast has to equal the weight of the thing that it's, there'll be some level of ballast tank connected or supporting the tube.
And you've also got a tube that the weight is shifting based on the traffic.
Yeah. And it's in a super dynamic environment. It's in the water, so there's currents and stuff moving the whole time. And so you would typically propose to build these things in sections and then join them. Usually the common methods are like some sort of like mechanical coupler, and then you grout the joints. Similar to, I think, the Fehmarn Belt tunnel, I think that typically these are like connected and there's water in them. And then once they're like all connected up, then the water's pumped out so that you don't have like a buoyancy problem at the time. But it's all theoretical.
How are the pontoons floating? Is it like a floating concrete, or is there something else involved?
There's typically like a ballast tank, so it's full of air. You're trying to make the tank as light as possible, so that it basically is displacing maximal volume of water, because that's what's offsetting the weight of the rest of the thing. If it's a watertight tunnel, it will have its own buoyancy as well. So it may not be a separate pond, because what's proposed, there's different designs that I've seen. Most of them have the pontoons sat on the bottom of the seabed, and they have cables coming up to the tunnel. And so that would imply that the tunnel itself, including any like ballast tanks on the outside of it, is the buoyant thing. And these pontoons are like anchoring it down to the seabed, as opposed to there's some other designs where it looks like they're on top.
And obviously there's going to be movement in these floating pontoons. So from a tube point of view, how do you deal with the connection points to give it flex?
Yeah, no idea.
Like a tube, like a train on the tube. It's got the rubber bit in the middle. You obviously can't have that because of the pressure of the water. But
yeah, you would normally have like movement bearings or elastomeric bearings and stuff, but you also want it to be watertight, which adds another level of complexity. And the whole thing kind of hinges on it, hence probably why they've never been built. I think there is the part of the proposal for this one in particular is that the actual shape of the structure, if you look at it from the top down, from a bird's eye view, it has a big arc to it. And I believe that's because that's like arcing into the direction of the water flow. So same as like it was, I guess, the opposite of what you would see typically for a dam structure, where it's kind of arced back towards the retained side so that the pressure pushes it into the walls. This is like curved away so that it's not trying to hold itself like perfectly straight. But it is a one of one project, which opens up all sorts of epic risk associated with it. So it'd be interesting to see what they end up trying to do here.
Be interesting to see, because we've got the floating tunnels or the floating bridge. Which one's actually more difficult from an engineering point of view? Because the bridge, you don't have the issue then of like water pressure and obviously the elements beneath the water. It must be it's much heavier because you haven't got the support of something being placed in water, which is naturally going to make like a concrete structure lighter. I wonder which one is the bigger engineering challenge.
The bridge one has a whole bunch of other questions on it, because you've got as you said, this heavy structure sat atop where the buoyant thing is. And whenever you have the like weight above the buoyancy, it's inherently unstable. Like if the center of gravity, it wants to tip over, basically, is what you'll typically have. Like if you've got it the other way around, what typically happens is if the center of gravity is below the buoyant thing and it becomes like off center, it wants to correct back to under the center of gravity. Whereas if it's on top, it wants to flip over. So, when you start thinking about designing for storm events and wind and all that sort of stuff, you've got this thing that kind of like, if it gets too far out of kilter, the whole bridge wants to just do a big flip on top of itself.
I don't know if you remember the opening of the Millennium Bridge in London. Did you see? Remember that when it opened on the day, it started to like wobble, and then
Mm.
eventually it was doing like that, and they had to like shut it, and something to do with the tension of the steel running through it. But
Yeah, yeah, yeah.
it pretty rapidly became some sort of freak theme park ride.
So yeah, I think there's some question marks on some of the more. These are obviously out there proposals for some of the more difficult to cross fjords, and they're for the ones that they have, like, let's say, slightly more conventional solutions for. There's some work underway, so super interesting to see what they end up deciding to do, and obviously the probably helped by a successful continued delivery of the first of the tunnels over the next 6-7 years at least.
Yeah, for sure. That'd be a good one to drive one day.
Yeah. The article starts with, for those of you that have driven the western coast of Norway. So I don't know how big that list is. All right, so jumping to a totally different topic. In the last week or so, WSP and Microsoft have announced that they've entered into a 7-year global strategic partnership valued at over $1 billion, which was the catchy headline, with the aim to accelerate digital transformation in the built environment through AI and engineering innovation. So it's like a big number and every buzzword that we can think of in the announcement. The collaboration positions WSP as Microsoft's preferred engineering consultant, while Microsoft becomes WSP's preferred partner for digital and AI transformation, which includes the global rollout of Microsoft 365 Copilot to WSP employees. There's a lot in this. I think probably the first question to kind of ground on is, how consequential do you think it would be for either or both parties?
Yeah, it's an interesting one because all we can see is what we can see online, but there's some quite sort of obvious pros and cons for each party for the deal itself. And I guess if we think about from WSP's perspective first, obviously it's a great announcement for them because it will help build their reputation and brand in that space on probably one of the fastest growing sectors of construction at the moment.
Yeah, so just to add context for people that don't know the announcement, one of the big elements of it from a WSP perspective is that Microsoft have elected them as their preferred partner in design, specifically with regards to the pipeline of data centers and energy and stuff that Microsoft has to build to meet its like data center and cloud and AI ambitions.
Yeah, so with repeatable business over a long period of time, like they will build a lot of experience in the space. It's an attractive proposition for other organizations wanting to pull in their expertise. So it's good. Yeah, it's a good steady stream of work. And it's such a steady stream of work, they can really strategically focus on potentially building out that as its own isolated division or sort of part of their offering. So that's a clear win for WSP, you would expect. The flip side of that is, I guess they're betting on Microsoft to an extent, going into a partnership like this. If they go in all in on a partnership with Microsoft, are they potentially limiting what they could do with Google, with Amazon, with other players in the space? Obviously, as you pointed out, it's not the worst bet in the world, but yeah, if Microsoft doesn't end up being the high performer in the space, you've bet on the wrong horse, is a risk. And those partnerships, we don't know the details of this agreement. There might actually be limiting factors that Microsoft have given WSP for having this exclusive partnership.
As in, like you're talking about the idea that they have a non-compete kind of restriction.
Exactly. Yeah.
Maybe. Yeah.
So yeah, is it an all eggs in one basket type kind of proposition?
But it almost doesn't matter whether Microsoft, let's call it, wins or what their AI offering is, because ultimately, from a WSP perspective, it's like, will they build infrastructure? And the inputs to that are like, do they have the money and do they have the opportunity to kind of like go and win? And it's definitely like a yes and a yes. So even if they don't, even if they spend all the money and it doesn't win. For WSP it's wins. Like, yeah, WSP is still happy.
Yeah. From the Microsoft, sorry, go ahead.
Yeah. No, that's what I was just going to, I was going to prompt exactly that. So yeah, keep going.
Yeah. So from a Microsoft perspective, like is partnering with a engineering company like part of their strategy, because they do bits and pieces in the construction space. So is this a two-way street in terms of learnings, and opportunity for them to potentially try and capture more of a market or think more in that space? Because otherwise it's hard to see like what's in it for them. Yes, WSP things might become more efficient, so each one's better than the last, and they could win from that gain. But it feels quite a heavy win for WSP. So maybe there's something in it that we don't know with Microsoft and Microsoft tooling.
I think you've captured the what's in it for WSP pretty well. For Microsoft, I think the game that they're in is like, if you think about it, we've got OpenAI, which runs historically exclusive on Azure, which is Microsoft's cloud, basically needing and running out of compute capacity on Azure. And that's part of why this big Stargate announcement, et cetera, came. So Microsoft's under a lot of pressure to build out compute capacity for AI. And so for them, it's a speed game, I would guess. And so this agreement probably gives them committed resources, a team. They don't have to go to every time they're going to build one, go and find the right partner, see if they've got capacity, compete in the market for other designers. They've got a team that's just going to keep doing it for them. So it's probably optimizing towards speed over cost is what I think is the primary win for Microsoft. There's also, like you said, maybe they're repeating the design over and over again, and that starts to drive some like efficiency on top of itself. Then there's this whole other part of the deal, which is to do with like rolling out Copilot across WSP, which seems like someone decided to pop that in at the last minute into the deal.
Also, do you mind? Yeah, fine. It's fine.
Like they've got 73,000 employees, WSP. So rolling out any tool across that many people is non-trivial. So I don't want to be overly dismissive. But at the same time, there is a lot of conversation about how Microsoft's Copilot AI offering has been somewhat of a flop. So for context, and this is like a little bit talking his own book, but Mark Benioff, the founder of Salesforce, has repeatedly called Copilot a failed product. He has referred to it as Clippy 2.0, and that he said customers barely use it. Microsoft was obviously pushed back, and their claim, which seems like super woolly to be honest, is that they've had 60% year-on-year growth of the product, which I don't think it's that old, but I can't imagine that they were starting from a very big base, and 60% on not a very big base feels like not very much. So it's hard to fully validate. There's a lot of conversation on the internet, if you're hunting through Reddit threads, basically roasting this Copilot product. So I can't imagine, back to the WSP discussion, that they were chomping at the bit. It does feel like can you build a house for me and then I'll also walk your dog in contra payment? It seems unrelated to the thing that they're trying to do, which is design and build data centers.
Yeah. Have you used it? Have you tried it?
I have I've obviously, we typically run on a Mac, and I have a virtual Windows machine. So I do play around with it from time to time. I can't claim to be a daily Windows user. So I don't think I've fully tested its integration to all workflows, but no, it's pretty bad. It's disconnected. You have to really know. It's kind of like a Siri in that you really have to know what it can do and what it can't do deeply. Otherwise, you spend a lot of time asking it to do stuff that it's I attempted to do this and it's bad answer.
Yeah.
So when you ask Siri to do stuff and it's here's some internet results.
Yeah.
You get a lot of that happening.
So so do you think, from Microsoft's point of view, this 70,000 boost in Copilot user numbers, is that a sweetener for a deal, or is it just something thrown in? Because if it's just something thrown in, then what is the sweetener for Microsoft? It still isn't that clear why they benefit.
I think they need the WSP committed resources to help them build data centers quickly. They're getting a lot of pressure, which is basically they had exclusive rights to be the cloud provider to OpenAI, and the Stargate deal basically opens that up now to Oracle and other people. And so I think they're under a lot of pressure to build compute capacity for AI. And I think this deal is basically like, hey, we're going to build X number of data centers. Who wants to come and bid to be the design partner on all these data centers and can resource it and have the team and stuff? I think that's the like crux of it.
Yeah, yeah. And obviously for WSP, having that sort of deal in place, you really can go at it with confidence of go and mass hire, upskill, and do everything you need to do for that steady stream of data centers. So if that's going to be part of your sort of core strategy, it's such a huge lift to get you going into that space. And potentially try and
really good win for it's definitely a good win for WSP. It's also like an attacking move from Microsoft. So the like strategy, like if you and I were going to go to court over an issue, there is like a strategy I can run, which is engage every good lawyer in town. So that they're conflicted. So if Microsoft basically can turn up and offer to pay whatever rates that WSP go, this is awesome. It's another like big player, one of the biggest players with 70,000 people out of the market that now a Google Cloud or an Oracle may or may not be able to employ because they've got their resources committed.
Yeah, for sure. It'd be good to be a fly on the wall of that meeting that was had when they were running through the strategy.
Yeah, it's interesting the numbers that build up to it's worth $1 billion. That bit there, I wonder if they're including the 72,000 seats of Copilot in there. Which
it's an adjustment on the end of the invoice. Oh, we're negative to however many $1 million for your licenses to Copilot. Thank you.
I think it's like $8 a month or something. This might be totally wrong. I think the Copilot add-on's like $8 or $10 a month or something per seat, which that's only worth $7 million a year. So there's still $993 million to make up the $1 billion announcement.
Yeah. For sure.
So yeah, interesting. Righto. I'll intro this third topic and I might just hand straight to you because you were the one that like found this. But basically there is a company that called HiArc, HiGHARC, which demoed or showed off a new feature / product. So it's a broader company that does other things, but I think they've got this core functionality that they have deployed, which effectively allows someone to take a sketch of currently like a residential building project, so a house, and it will magically convert that thing into 3D models and like fully compliant designs of the house. So it's built on top of this whole bunch of repository around codes, around room sizes and positions of all these things inside of residential builds. And so yeah, the videos are pretty cool. You're literally sketching the floor plan of a house and then suddenly there's this house coming to life in front of you. Yeah, what are your thoughts?
Yeah, really cool looking tool. And you can imagine if you're the person looking to purchase a house and you're sat with someone who in real time is sketching together this plan, it's changing in real time and you're looking at the model output. Obviously, great way to communicate what the thing that you're designing looks like without this huge lag in going away and producing drawings and the things that take a lot of time and a lot of cost. So I was trying to think if we could take that sort of technology, because at the moment it is within the context of like houses, super simple. How could that sort of technology be applied to complex projects? And a few things would be, firstly, real-time exploration of design options. If you could be doing that in a complex scheme with the right people in the room, the efficiency of that time to think through ideas, ultimately update the model in real time. The model then comes to its strength of doing things like clash detection from a design point of view, and have the sort of metadata related to the whatever you're building behind it. Mm-hmm. You could have super productive meetings where you could be exploring multiple options within a very small period of time, where at the moment you've got teams of consultants going away and doing very in-depth stuff to try and work out if these things are a reality or not. Mm-hmm. So that feels like it could be a huge win. You've got changes in the field. So those sorts of things, obviously you'll give me a lot more light on what that process actually looks like. But anything from, I don't know, a rebar cage that doesn't quite match the space or whatever that might be, the process of going through and getting the field change approved, if it's something that you can pretty quickly get into a model and then the model validates that it works within the space, could be a huge win. And then the third one that jumped out was like subcontractor engagement during tenders. If you could be, they could be presenting you these options in real time tied to a model, which they would never have the resources or want to commit the resources to doing that sort of level of depth for a tender. But now suddenly it's quite easy because you can do it in a small amount of time. You can be going, here's 3 different options for this space and the design that's required. It just opens up so much time to explore ideas without the huge cost behind it.
I immediately get drawn to the feasibility of I totally align with the, what would be possible, and I immediately get drawn to the feasibility of that. And so the reality is that the housing market, a lot of the building or the design of a residential house is code dependent. So there's rules around spacings of battens in walls. There's space, you have
like a playbook for every object, basically.
There's a playbook. There's not a lot of bespoke design that's typically happening, usually maybe a little bit on a foundation, but the actual layout of the house is often basically rule dependent. And so this is able to take in the fact that there's all of these rules. There's things a room needs to be at least this big, or there's rules in different geographies of the power point needs to be this far from a water source. They can do, code in there door swing clearances. And they've even, I think, got a fully digitized library of all of the typical components people would buy and put in their house from Home Depot and other providers. So islands and cabinetry, that all, the rules around all that can kind of be known. And in civil or larger building type projects, there's a lot of first principles engineering that is happening that goes back to the size of a beam, that are not rule based, but they're underpinned by physics calculations and engineering calculations, which means that the data set and the availability of the information to do such a thing is fundamentally different.
But the physics is still a set of rules, right? So even if you go back to first principles, it's still a set of rules that AI could understand and know and apply alongside any project-specific rules within the works information.
Yeah, you get into it's kind of describing maybe some structural design software that's out there. What's hard is the interaction of okay, we've got the structural design,
real-time considerations.
What does the architect want from the light to look like? It's just, you don't have this. There's a bunch of other considerations that aren't kind of encoded into the system.
But even if you strip it back to on most major schemes, there's a concrete box or structure involved, and just having that for concrete would be a huge time saver, because that's mostly where the space that you end up with is sort of contained within, irrespective of architectural finishes and
almost even if you take let's say we took a station box and you said that that's a concrete box, 99% of that, some vast majority of the design consideration for that is the earth conditions on the other side of the concrete box, which is driven by borehole data and surface loading data. So it's not just I sketch a box, I draw a box and then there's a lot of fundamental design inputs that have to kind of go into it. And that's, it's a much harder it's just a different problem to solve, and probably harder.
Yeah, definitely. And it's definitely not, I can't see it popping out somewhere this year, but the concept of it is pretty cool. And then they even had spin-offs on that of it's updating your bill of quants in real time. You go, yeah, cool, I like that design. Cool, here's the price.
That's that. I thought that was really cool, because obviously they've got, I mentioned, that library of things from Home Depot and all that. They know the typical components that people would build the house out of. So you can, you can generate option A costs this much, option B. It's very, very compelling. Would love to see it in broader, but it would also be really handy take a smarter person than me to solve it. So anyone in the world, basically.
It would be really nice and comforting for anyone that's doing an extension to have that sort of software, because you're not being fleeced by a builder who's just plucking numbers out of the sky too. So that would be handy.
on that slagging off of builders, shall we wrap and you want to read us out?
Yeah. No, thank you very much, everyone, for tuning into today's show. If you did enjoy today's episode, please do think about liking the video or following us on your chosen podcast platform. We really do appreciate your support, and we'll catch you all next week.
Bye-bye.